Alright, time for another draft. Physics.com, debatephysics.com also, but I can't find any place to do this debating thing. You can't debate on forums, you can't debate on Wikipedia, you just can't debate. And if there is a debate, it isn't enough of a debate, to actually pick, all of the experiments and all of the stuff to pieces and find the real truth. And there's so many simple arguments that can be made. So I've made arguments about energy and the fact that its energy duality of momentum and kinetic energy is ridiculous. It's either one or the other. You can't have two different answers for what energy is. Energy is mv, or energy is 1/2 mv squared. And I've pointed out all the places where obviously the kinetic energy theorem does not match reality. It doesn't take 25 times the fuel to go 5 times as fast, and if you're going 5 times as fast, you're not going to do 25 times the work. Just not going to happen. Doesn't happen, frankly. Period. Should be the end of that conversation. And the simple argument underlying that is people are being fooled by something kind of obvious. That is, you can apply energy in different ways. You can apply it quickly, you can apply it slowly, you can apply it in a small area, you can apply it in a large area. And that's what makes a difference in how you have a different effect. So you can essentially break the structure of something, defeat its structure, and that will allow you to make it appear as if you did more work, but you didn't really move more matter, and that's the key point. And so the application of energy is being confused with, how you apply it. The efficiency of your application is being confused with what your actual energy is. And, it's a very simple argument. I don't think it can be reasonably argued or defeated, because every example I can provide will show that that's exactly what happens. Bullets deceive you, okay? It's just, yes, a lot of action happens in a very small area. Small amount of mass is disturbed, and that's the truth of it. And it looks like a lot of stuff happened, but a lot of stuff really didn't happen, in the sense that all you did is defeat the binding energy of the substance the bullet went through in a more efficient manner, with using high velocity. And that's all you did. But you didn't break the rules that basically say 1,000 atoms going 1 mile an hour is the same ability to move matter as 1 atom going 1,000 miles an hour. You can't move more matter. You can't give more matter motion. And that's the simple principle. Well, anyway, didn't want to argue that. So that was already a huge off the subject. So anyway, there's this channel I found called the DemystifySci podcast, and it's got these two people, a woman, Anastasia something, Bradenberry, and some kind of Michael Soto de guy or something. Anyway, and they seem, they're kind of young, got some science education, and they're sort of mixing a bunch of philosophy into this, realm of science. So it's kind of implying that it's about physics, but it's really not. And that's the real problem. It's all over the place. I guess some people find that appealing, but to me, I don't, this is like, generic mixed vegetables or something. I don't see, doesn't work for me. Keep them separate. I'm just not really hungry for these random explorations into multiple subjects in some superficial way. It just doesn't seem much point in it. And the real point is to really try to evolve some kind of argument and get it to the real substance of the argument. It's just, you can just go over all these subjects and all the misconceptions. You could just argue about, 4 times the distance, falling in gravity is 4 times the energy, when, when you go 4 times the distance, it's only 2 units of time. So you only got 2 units of acceleration. So how could you have 4 units of energy if you only got 2 units of acceleration? Come on, it's just, I should, a real debate in some sort of real arena where you have to take account for what you're saying, the argument should be kind of over. Anyway, so again, I'm arguing the science. They didn't really want to do that. So they have, they don't have much, the videos get an average of a couple thousand views, so it's not, hugely popular. Again, I think the format is probably the biggest problem, because they are literate, scientifically literate, and they don't seem to be saying anything completely ridiculous or defending anything completely ridiculous, and just seem to be saying, the answers we have aren't really good enough, which is, the starting point to me for the reasonable conversation is for a fair person is going to say, yes, this just really isn't good enough. This isn't a very tight theory, these physics theories. And they need to be tightened up. So anyway, so having said that, so they have done a couple of years worth of interviews with different people. I guess the most notable was the Mathematica guy. I haven't watched that video yet. I don't like the format much. I just have to say, it's just too much sidetracky stuff. It's just not enough physics, and it's not direct enough. And so so as part of their show platform, they're doing this thing called paradigm drift. So they allow all these different people who have something to say speak for 1 minute, and then they talk for 3 minutes about the 1 minute subject, and again, way too superficial to do any good, I think. And obviously they don't have the view numbers to make it really worth your while to sit in a waiting room for 3 months, because of the way they've designed the system. You have to 30 people sign up and 10 people get to talk, so you have to so you could, if you're unlucky, spend 6 months in waiting to have your turn, and obviously that's humiliating. So I haven't signed up yet, because I'm not sure I'm willing to be humiliated. I'm that desperate for the conversation. So I have requested a real program where I get to have an hour or two to babble about the truth, and we'll see. But whatever. So the funny thing was, there's a whole list of these whack jobs talking wacky shit, and then David D. Hilster was in there. So I just thought, so he actually had been interviewed for a couple of hours in a previous episode a couple of years ago, and then he signed up to do the 1 minute thing again, I guess, and so I was saying, so it's, the desperation it's tragic, that this is what you have to do to get any audience at all to listen to your arguments, and there really ought to be a better platform than this kind of amateur, hour kind of gong show. Maybe it's, it just isn't, it's not going to get there. So we know that, of the, if there's 100 cranks out there, only 1 in 100 is going to actually be talking sense. So that's the real problem. So it is disappointing, and this is a terrible process. Physics is a closed system. It's, it really should be argued every day. The physicists should have to defend their wacky crap. But anyway, so I figured I'd just play the D. Hilster part. Now, the thing about D. Hilster was, I've listened to all his stuff. He has some of it so right, in the sense that he figured out that it's a push-averse. So he's got the push-averse part right. He's figured out that, it has to be a physical process. There's physical processes that cause what happens. There's not magical processes. So whether you call it particles or not, doesn't matter. They're obviously in discrete little places in the universe, and It's just sensible to recognize that. And he's just recognized that ether is crap, but the problem is he's accepted an ether system to define charge, and so that was just a huge mistake. So he comes up with this idea of a push and particles, and then he has sticky ether as part of his system for creating the most elemental function, which is dipoles and charge. And I've tried to explain that to him in previous videos, that you really can't say charge is arbitrary. It's a ridiculous statement. It's the most elemental function in the universe. The opposite reactions that protons and electrons have to the same force field. So the same force is coming towards them, and the two things react exactly oppositely. I mean, that's a huge phenomenon of nature, and you can't call that arbitrary. But anyway, so and then he resorted to coming up with some, he's got the idea of particles, photons being particles, and then he has another faster than the speed of light force controlling the photons, which is just too stupid. Well, it's too wrong. You should know you can't go there. You can't go to anything faster than the speed of light, because then you create all of the time paradoxes, where something's going to happen before it happens. It's just too ridiculous. All right. So, I think that's probably enough of a preface. We'll see if this plays and such.
Same Zoom time, same Zoom place. All right, we got the Hilster.
With Fargo, your virtual assistant from Wells Fargo,
disappointing.
you can quickly know what you spend on.
All right, so they got the Hilster in the room, she says. And, they do, like I said, this is just way overdone. The connection, the physicists who are all into this music thing, and it's not really good music in any way. Just like, what the hell is that? I don't get it, but whatever. I don't get a lot of things. I just don't understand human beings. It's just, I don't understand stupid, and there's just way too much of this stupid thing going on. But anyway, continuing.
He is under the sea. I love the nautical.
All right, so it is kind of funny that D. Hilster's hair, he's got orange hair now too. What the hell is that? But anyway, desperate. We're actually, I think, at the same age, and our birthday, I think, is the same day, which is just kind of funny. Coincidentally thing. But anyway, just... shit. Well, anyway, let's go. And then there's this other person in the room who never talks with this, mask on. And, kind of no point in this.
Theme down to the shirt.
That's just blue screen. A real blue screen.
Man, add like a little bit of wooden trim.
Yeah, his blue screen never was very good, because you got to do the lighting thing and the whole thing. But anyway, now that he's got orange hair, he's really in trouble.
To the edges, and I think the vibes.
I put some of my art back here, but it's really so close. But it's been crazy. It's great to see you guys growing, and I wish I'd been able to. I've been going nuts.
So it'd be great to see you guys growing, right? They're not. Shit. It's not growing enough. I mean, really, physics has got to do something about, creating this kind of platform, but on a platform that actually somebody can watch. I mean, it is, to me, like I said, to somebody scientific, and you have this interest, and your interest usually is focused on subjects, and they're not, any physics subject I find a little bit interesting, but obviously some of them are, and it's just, no. It's like if you value your time, you're just not going to sit there and say, okay, I want to listen to 20 minutes of crap. It's like watching the whole D. Hilster video, the 2-hour one, 3 hours, I don't know what it was, and he's going to talk about expanding Earth. I mean, I'm not going to listen to that crap again. No way.
I've been talking around the world on a computer programming language I invented 25 years ago for AI and NLP. I've given classes in India. I've got hired by Northeastern University. So we need to talk
Yeah, to do what exactly? But whatever, who cares? Okay, fine. You're an AI expert.
about the AI. It's not around the corner. It's not going to threaten us. I've been in that area.
Well, I'm just saying, it's obviously going to threaten you if you do have a job. You're going to be threatened because obviously it's going to start, you know. You don't need the people to answer questions anymore. I mean, that's, you know, it's a pretty big thing happening in the world is people who answer questions, technical support, whatnot.
For like 4 decades, but today I'm going to talk about physics.
All right, I love that, and yes, absolutely, let's do it. Are you ready?
Yeah, let's do this
Silent
on 3.
delay?
We're gonna catch.
Okay, so they gave them 1 minute to sit there and try to summarize a challenge, I guess, to some established theory, and you're arguing that something else is more important kind of thing. And this is really hard to do in 1 minute and not much point.
You in. All right, here we go. 1, 2, 3, hit it.
All right, light, gravity, magnetism, and electricity all travel at the speed of light.
Right, so now I've been saying that for 15 years. You know, it seems an obvious. Okay, so let's just understand, yes, they're all going the speed of light. They're all in this discrete form. I mean, the gravity goes right through us kind of thing. I mean, it's just so obvious that this is all the same crap. And there's no point in pretending it's some other crap. It's all the same crap. And you're just saying, what's the difference between when it's crapping magnetism and when it's crapping photons and when it's crapping gravity? What's the difference? And I would argue that the obvious difference is the difference created by electrons and protons, the charges. And if the charges are in different positions, well, they create a different pattern. And if they're moving different velocities, they create a different pattern. You know, not too complicated.
And therefore must be the same particle. It sounds
Yes, it sounds perfectly reasonable. So yes, so why is this? Look, I can go back to Newton's bucket again, right? So Newton, the first argument he makes in Principia is the argument that physics ignores the most. So his first argument is completely ignored. I didn't realize he even made it until you go do some research and you find, oh, Newton has this great argument against relativity. And he made it before Einstein. So obviously he made it because there were people like Huygens and even Galileo that were kind of talking about this idea of relative motion. And he wanted to just dispel the idea that the motion itself is relative. The universe is 3 dimensions, and there's stuff moving in the 3 dimensions, and there's no warping or bending of that system. And that was Newton's argument. His bucket experiment is great. And then he uses, you know, the 2 balls hanging on a stick, and if you spin it, the balls fly out, proving there's no equivalency principle. That the idea that the whole universe spun, okay, isn't going to work, because that's not going to make the 2 balls fly out. So, in my opinion, physics never defeated that argument, and yet they jumped into this relativity bucket. You know, it's just, they don't have good reason to do that because Newton's argument is sound. It's a universe of 3 dimensions of space, of positions. That's the truth, and it's not warped.
preposterous, but this notion actually works remarkably well. So far, we've been able to describe all the forces in the universe with these 4 motions.
All right, so let's understand. He hasn't described anything, but okay.
Gravity is random motion of these particles. Magnetism consists of...
So again, it's, you know, that was my first guess, you know, is that you can just randomize it, but it's really just the word, a better concept to understand is that it's, you know, broken photons, pieces. So the pieces, you know, where the magnetic pattern isn't quite right or the photonic pattern isn't quite right, that's all stuff we can't see. Because we detect things based on creating a magnetic field or creating a frequency. And without those 2 things, we can't see something that happens. Just like we can't, you know, in a lot of ways see, you know, some of the photonic spectrum without proper instruments. So we just don't have an instrument for the temperature of the universe, because we can't make something to, you can't make a device to detect something you can't evade. If your measuring stick is going to be the same temperature as the universe, you can't measure the temperature.
Interacting orbits of these same particles. Light consists of waves of these particles traveling together like
all right, so he shouldn't say waves because he's trying to make an argument for particles. So as soon as he says waves of these particles, there's no, you're already breaking continuity, and so there's no point in just saying it. So, just say they're coming at a frequency. Stick to the facts, okay? Because that's the important part. They don't have a wavelength, they have a frequency.
Waves of bombers. And electricity are the particles flowing in one direction guided by a lattice of bodies such as atomic nuclei.
Okay, so the nuclei really aren't doing anything with electricity, so I think it's plainly wrong. It's just the valence electrons being pushed along and creating pressure between each other, and as alternating current kind of proves, you don't really need to move the electron to a new location, you just need to get it to move, period.
Motions occur at all levels of the universe, which there are infinite, and reveal how electricity generates magnetic fields, how atoms...
Okay, electricity causes atoms to change their condition, their shape. So you could just argue that when you're moving the electrons of the atoms are changing their shape. And all the magnetic effect is the fact that you've changed now the pattern being reflected off the wire. The wire isn't excreting any new photons or any energy. It's just reflecting now as if, okay. So it's not, so the magnetic effect, that is actually the effect that causes induction, those photons are now polarized in the sense that their shape has been changed, so now they can cause the same effect in a wire a mile away.
Emit light, how magnetism induces current. It also reveals how electrons are kept in orbit by a smaller gravitic field moving faster than the speed of light.
So this part, you just should have never gone there. I mean, that should be somewhere you only go if you're so damn desperate and you just can't think of anything. No, I mean, it's the least likely kind of area to go into is the idea of even contemplating some kind of concept. You're saying you have a force going the speed of light. It carries a momentum because it obviously affects substances. If you create something underlying that's moving faster than that just creates all kinds of mayhem in coherency with reality, because there's just no evidence of that.
And explains why Coulomb's and gravitational law equations are both inverse squares. With the four universal motion...
I mean, obviously the inverse square law covers the light bulb. I mean, it's anywhere that you have a spherical source, a symmetrical source of anything. And so, I mean, the inverse square law isn't some special concept. It's just this idea of a radiator, a convergence or a divergence. The fact is it's diverging. I can make my hands do this, and then I can make my hands do this, right? So it's in two dimensions. It's spreading in two dimensions, or it's confining in two dimensions. And that's all the inverse square law means. So it's not all that, it's technically not even an issue in understanding that obviously anything in space, if I had a field of BBs in random directions, each BB would feel like the whole universe is out to get it, because that's exactly what's going to happen. All of the BBs in the universe will seem to be converging on it, because the only ones that are going to hit it converged on it. And so if you took away all the BBs that didn't hit the object and you just showed the path of the ones that did, it would look exactly like a light bulb in reverse.
We can visualize the entire universe without any mathematical operations. equations. That's it.
There's no point in saying no math, because you're saying the math is just a formalization of your pressure equations, how your volume equations, how much equals how much, and all of that stuff. And why pretend that isn't part of the subject?
Hey.
Not bad, not bad.
Come on, guys.
That was well done.
Baby the Hilster in the house. All right, man. So unified
I hate shows.
field theory of...
Well, no, it's not really what it is.
Unified field theory. So it's a particle model. I guess first and foremost, it's a defense of a physical model of the functions, saying that the force is a physical object, bits of force.
No.
Unified particle theory, sorry.
No, not even close.
Hold on.
Particle theory, no, he says. Obviously, it is a particle theory.
Hold on. Is it a unified theory, though? Because I'm on board with that.
Well, it's not. I don't know if it's a unified theory. It's a.
So again, it's just, I don't know why he's hemming and hawing, running from those words. He just says it unifies the four forces. He didn't really talk about the strong force. Because he says charge is arbitrary. Obviously, he's not going to get the right answer to the strong force. And he's going to talk about this Denou crap, which is an ether theory. Okay, basically, you spin things inside a swimming pool, and you can create a tiny bit of attraction and repulsion. Tiniest bit. So if they're spinning in sequence, they'll attract. If they're spinning opposite each other, they'll repel. And it's because you're moving all the fluid, because it's sticking to the objects you're spinning. And it's such a poor comparison to almost the straight line vector theory he was almost defending. So he was almost defending a nice, sensible, the universe is just made out of vectors, nice straight lines. You could draw the whole thing in straight lines.
And the problem with all the unified theories, and I'm a mathematician, I've got a bachelor's in mathematics, is that
A bastard.
they're mathematical equations that are empirical equations. You look at the world as an engineer and it says things move like this, and you make an
Okay, look, there's just the effects, and then there's defining rational causes. And so the equations are sensible. It's sensible to say, how do I measure energy? Well, you take the mass of something and its velocity, and that works rather consistently in terms of all you're going to do is transfer that momentum. That has to be conserved. So that kind of thing, you formalize it, it makes sense. But where's the sense in the 1/2 mv squared? There's no sense in that, because it actually doesn't happen. It doesn't describe the effect.
equation for it, right? You don't say, oh, what is gravity, by the way? Oh, and what is magnetism? In fact, we don't even have a magneton. We have electric field.
Right, so obviously, I don't know why he didn't just say that one too, if he believes it. I'm not sure he does. The electrons and the protons are the magnetic monopoles. Electricity and magnetism are made out of exactly the same physical force. The amount of force is exactly the same thing, and all you're doing is changing the pattern of that force.
Fields.
Both things. The light bouncing off of you, you get it? It comes in all kinds of different colors. It does all this, interesting effects. You didn't create it. It's not excreting out of you. It's reflecting off of you. Okay, it comes in and it's reflected at a different frequency than what it came in as. That's what's really happening. So you don't generate it. And so you don't generate magnetism. It's just another type of reflection that we can't see. But it's another pattern. And it happens when when the force hits a magnet, it reflects a quality that we can't see. So we can see the color thing, but we can't see the effect of magnetism. But it's the same, it's just as dramatic an effect as color.
the Coulomb's law. You got a positive and negative. There's an attraction. Well, what is that force? The four universal motions, which we didn't discover them all. Yonel Denou did magnetism.
So again, he didn't do anything. I mean, it's a silly theory that somehow this duplicates one of the strongest forces in nature, magnetism, by spinning things, and it creates a feeble amount of attraction and repulsion. So it's obviously not the right answer.
My father found the wave-particle duality. If you know,
it didn't do that either. So they're still stuck in a very convoluted theory of what actually is happening when the photon is traveling through the slits, when obviously the only thing that's happening is the ones that hit the surface, are near the surface, are being broken, and the pieces are being scattered, and there's a 50-50 chance that you put a photon back together.
He solved the wave-particle duality, at least a solution for it in 2015, when he said that light are basically particles flying together in waves. So you have...
So again, there's no point in saying flying together, because they don't have to be together. They just have to, in some place, they have to land on a surface with a frequency. ... That's all they have to do. One dot can come from over here, a dot can come from over here, a dot can come from over here. Doesn't matter.
Particles, and you have waves, and then electricity. So what we're saying is that gravity, light, electricity, magnetism are all the same particle. They just move differently.
All right, so they don't move differently. They create patterns when they hit surfaces. They have different patterns. So you could understand that if I was to hit a surface and try to move an electron, that I could hit the surface, cause a group of electrons to move, and then I could hit the surface again, and then the electrons that are behind that second hit will get an extra little push, and then I can do it a third time, and I can give that electron quite a bit of momentum because I hit 3 times behind the energy that it represents.
When they hit your...
I matched its resonance motion, in a sense, that I added energy while it was still moving in the forward direction, the away, the pressurized direction. So before it could depressurize, elastically contract, I hit it. And so I just keep adding motion or velocity to it.
Your eye, they're coming at you in waves, frequencies. When we have them orbiting, when you have electricity, which is the same particle going through a wire, they'll stay inside, but some of them will go around on the outside and create these orbits.
So that's the buoy part, where he has no explanation for how they do any of that stuff, and some of them are doing it. Some of what are doing it. There's no pile of electrons outside the wire doing anything. So I mean, it's just not true.
And those orbits, when they meet together, like Yonel Denou shows in the water, those will attract and repulse. So
again, very weak theory, because the effect is so bad, and it's an ether theory. It only works because the water molecules are sticking to the objects. So there's just, here he is talking a non-ether theory, and he's using an ether theory's mechanism. So, I mean, that's like the first... You don't want to make those contradictions. You don't want to advocate for something and then say something completely contrary if you can avoid it. Now, I've said that, electrons are dragged. And now I've just proven that there is no drag. So now I have to say, well, then why do electrons not travel very well? They have the appearance of being dragged. And what I should have understood was electrons are charged, and there's no way they can see the world neutrally. There's always some place that's more positive than negative, and that's what happens to them. So even in empty space, where there's very few atoms, they still see those atoms, and they are compelled, in a sense, to interact with them. And once their velocity diminishes enough, they'll be absorbed by one of those atoms.
We didn't look for this and call it a theory of everything, but these four motions at all levels of the universe.
I mean, whether it's a theory of everything or an elemental, let's get the right universe defined. So again, the simple argument I can make is, a statement that I don't think anybody can argue with is the real universe is the small universe. Okay, all the actions, all the rules, all the laws happen there because everything I'm doing, they do first. So electrons and protons aren't being dragged by me, into doing things. I'm being dragged by them into doing things. So the real universe is empty space, electrons and protons. That's the real universe. And the force, of course. That's the place where all the stuff happens. So it's more like getting the elemental starting point right. And I don't know if there's a word for that. Unifying theory, it's not about unifying things that they disunified. Obviously, you don't need to unify the forces when you already know the forces are made out of the same thing. I don't need to unify the forces. And all you're really saying is this, okay, you have force, stuff moving the speed of light, and then you have this heavier stuff moving less than the speed of light. And that's the real conversation. It's about the elemental universe. It's about force and matter.
This level, but the level below and the level below.
Okay, so there's no turtles all the way down. Bullshit. The universe is made out of these objects, and they're quite dependable. The checkers are checkers, the squares are squares, the black is black, the red is red. Whatever the physical mechanism is, it's pretty solid and redundant. One electron does exactly the same thing as all the other electrons.
And the level above. So if you look at it, you can start to see that you can see and visualize everything in the universe. Magnetic fields, light, gravity, electricity. You can.
The point is that yes, if you just recognize that, okay, what is really taking place? Again, the atom. Everybody knows the atoms are, full of empty space, all of that kind of stuff. And so, what's really happening? What's creating the structures? And again, it's elemental to recognize and to just see it as, okay, so all there really is the charges, and the charges are creating this ability to be in arrangements that are stable, and those stable arrangements are elastic. You don't have to go much further.
See them. You don't need any equations. And even down one level, you have the G1 part, we call them G1 particles, but what we would call electrons, which are the same as photons.
So there's no point. He says the G1s are electrons, and that doesn't make any sense because the G1s are creating gravity, and he's just called the gravity photons. So it just gets so complicated because he just makes this continuity error. The G1 can't be electrons, and then you say the G2, unless you're going to say that there's the G3, okay? I don't think they did that. The G2, I think, is supposed to be the stuff that's moving or controlling the photons, the faster than the speed of light force.
They're going around, but they're down there. There are smaller particles going in random directions that cause a gravitic field, a very small one, and it keeps those electrons going around the atoms. And
So the gravitic field is the same gravitic field. Okay, so what's causing gravity of the moon and the Earth is the same force that's creating the attraction between electrons and protons. So that's just wrong to say there's two different gravities. There's only the one. And, well, look, the bottom line is again, I'm making the elemental argument that all you have to understand is electrons and protons, and you understand that there's a force pushing them around.
we can reconstruct
A force that acts inversely to one as the other.
atoms that way, and we can describe. One of the big things is here's the big thing. If you take your phone, right, you set it on your charger, right. Here's what physics today says. You have electricity going around in a wire. It induces a magical word.
All right, so yes, and exactly, they call things virtual photons. They just cheat all over the place. But the simple argument is when the electricity is going through the wire, it's changed the shape of the atoms. The atoms have been squished, so to speak, and so now they're polarized, and so now they're magnetic. And so you've just changed non-magnetic atoms into magnetic atoms, and now you're creating a magnetic reflection off the surface. and the magnetic reflection is going to hit a surface and reduplicate the same kind of motion of the atoms in. So you're just taking a motion that has a pattern. The pattern's going through space with that motion, and it's just going to recreate the motion in the object it hits.
It makes a magnetic field. What is that? They don't know. That magnetic field induces.
So again, the magnetic field is just the appearance. So the wire changes appearance, and it's blinking. That appearance is changing constantly. And so you can understand that it's when it's hitting a surface, it's constantly changing. So it's causing exactly the same movement that changed the appearance of the source is going to be the same movement that's going to be affecting the destination. The same pressure. So he believes in push, and here's a perfect example where obviously the wire, you could just think of the wire as flexing, it's pushing, on the field. And that oscillating field, that oscillating pressure, it's pushing, creating big frequencies, short frequencies, lots of different frequencies. Those are hitting the other side. You could just understand that, yes, that's all you're doing is creating a pattern by causing motion, okay, in the source object. I think I'll take a little pause. All right, continuing.
Is electrons in your phone, and it charges, but they have no idea. There's nothing being transferred. But all of us who set our phones on a charger are saying, "Oh yeah, there's electricity here, and it's going into my phone." But that's physics. If you go to a class in physics, they're not going to tell you that. That's not the way it works. And so
so electricity is just an effect. It's an event. Electricity isn't. Nothing, just here, that's electricity. No, electricity is actually moving something, okay? So it's more complicated than just saying electricity, in the sense that you're saying, yes, there's this motion and exchange between atoms, so there's lots of events taking place. It's event heavy. And all you're really saying is that, yes, you can transfer that pattern through space, but it's not very efficient. So the simple explanation is, it's okay, you're causing an effect that's causing motion in the wire, and that motion is affecting the field, and it's affecting it in all kinds of directions, and obviously your collector isn't going to collect all of that. So it's clearly not going to be highly efficient.
problem is they have empirical equations, mathematical equations, describe magnetic fields, describe how things go, but they do not tell you what a magnetic field is, what gravity is, what light is. And so that's what our four motions do. They all travel at the speed of light. Magnetic fields travel at the speed of light. We use them to particle accelerate. Light travels at the speed of light. We know gravity travels at the speed of light, and so does electricity. How could the...
All right, so somehow those are the four things he's talking about. But anyway, yeah, so they all travel the same. It's the same force. Is the simple argument. The bent space. If it's bent space that's causing gravity, wouldn't it be a bizarre coincidence that whatever the bent space is, the bent geodesic, it somehow works at the same speed as the photons do? Exactly the same speed. It's sort of ridiculous not to recognize that obviously gravity has some photonic connection.
Those be different. And so what we discovered through other people's work, Glenn Borkowitz, Denew, over 30 years, is that...
So these are all etherists, that he's taking initiative from, and just a bad idea.
That these things actually have, that they're just motion, they're just different motions of the same particle. And
As
they
I'm
actually
listening
happen
to
at the
you,
bottom.
I realized I have no idea how one of those induction chargers actually works.
Yeah, exactly. And if you ask a physics person, they will tell you it's induction.
Well, I mean, induction is kind of the obvious part is that it's a magnetic field, and then obviously it shows you this huge connection between magnetism and visible and photons. That obviously two things got to have a huge connection. Because you can just argue that, radio isn't, it is a magnetic field that's being transferred.
Induction is a magical word to them.
But is it just supposed to be removing the actual ions inside the battery back to the place where they're supposed to go?
Right, and so you're exactly this again. You're hitting the wire and causing the same change in the atoms that was in the wire that's producing it. So obviously, if you're duplicating the same change in the atoms, it's going to create the same idea of pushing an electron one way or pushing the electron the other way. And you know that's right because the only thing that works is alternating current. So you have to just vibrate the electrons. You can't push them in one direction or push them in the other direction. You have to vibrate them. So the fact that the alternating current is the only way the transformer works, the only way the coils can receive the pattern, is because they're just oscillating electrons. They're not moving them from atom to atom.
They don't have a look. Believe it or not, there's no explanation for it. My dad's an electrical engineer for his entire life.
We're asking how batteries work.
Yeah, see, I'm saying when he says there's no explanation for it, I don't think they really haven't paid some attention to those details. Like it's an alternating current event, not a one way. One way doesn't work, but you just push the electrons one side and you don't have any electrons to push anymore.
But you can charge a battery just by driving currents into it.
Sure.
What we are saying is that what we call an electron is the same as a magnetron, is the same as a photon.
Well, that part he sees, so he's got that part right. But he says charge is arbitrary, which is like saying north and south is arbitrary. It doesn't mean anything. It's the most meaningful event in the universe.
It's the same as a graviton. So it's going through the wires. While it goes through the wires, the nuclei of the wire also makes some of those go out.
So this doesn't happen. So nothing's going out, nothing's blah, blah, blah. It's just reflecting. So a magnet's sitting in front of you. Do you think the magnet is actually radiating like a nuclear isotope? Or do you understand, no, the magnet isn't doing a fucking thing. It's not producing any fields. It's not producing any energy out. It's just creating a pattern. The stuff that's coming from the external universe is what it's changing. And that change is what another magnet can see. And so now it can be affected by the force because the force isn't polluted. It's polarized. It's the difference between recognizing resonant frequency and ignoring resonant frequency. If you recognize the frequency, then you can push something very far. You don't recognize the elastic resonance, you'll get nowhere. That's the difference. It isn't about how much force it's producing, it's about what it's done to the force, how it has filtered it. Filter is should be a huge concept in physics, because it's really, everything just acts as a filter. It changes something. And we can detect those changes.
Side to create a magnetic field. A magnetic field are just electrons going like this.
They're not just going like this for no good reason. No explanation for how they go like this.
Those electrons are reaching up into your phone and they get captured.
Alright, so the electrons are not traveling to your phone. It's not happening. There's no electrons moving from the source to the destination, so it's just wrong. Okay, induction is not about electrons being shot anywhere.
By the wires. And
how do these particles know where to go?
I was going to just ask that. Such a great
Yes.
question. What makes the wave?
Well, so that's the same question. What makes the wave and where they go? They go, obviously, everywhere. And that's the great giveaway too, is that you're going to have a coil of wire and then you put something in the middle, and what you're really doing is concentrating the force, because the stuff going towards the middle doesn't have anywhere to go.
I'm sorry?
What makes the wave? Like, is this a pilot wave theory?
Are you talking about like a light wave? What?
Well, I say you just pointed out. So Dave said, "What, you're talking about a light wave?" Yeah, you said the word wave, so now you have to account for it. So we should never have said the word wave.
Makes them come in waves?
Well, you're just basically
What's
like, they're all
waving?
the same thing, and they come at
No, they're
you
just
in different-
particles, and there's actually below it, there's another set of particles which also work down there. So what?
So again, that vague reference to this other physics that's going to happen in the other tiny verse. So we have a tiny verse, and then we have the, tinier, and then we have the mini me, and then we have the blah 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 blah, and it's this infinite theory of universes, and screw that.
Light, for instance, you have what we would call electrons. We're calling it the same particle.
So again, it keeps calling things. Electrons are not photons, so again, it's just a huge difference. You got to get that right. The electrons have to be pushed to have momentum. The force, the photons, always have their momentum, and they never stop pushing. They just find something else to push.
G1. It's going around nucleus, and there's actually a lot more going on there. But there's going around. There's a quantum of these things.
But why are they doing that? Like, why are they?
Yeah, because
what
there's
keeps them held
another.
on?
There's a G2 particle, a gravitational field, which we call Coulomb's law, which is a smaller particle.
Okay.
What we call, and it's going faster than the speed of light.
It's just, what a gigantic mistake. Just lost all credibility. You just break all kinds of continuity subjects there. You just cannot possibly create some mechanism that causes any effects, okay, and say it's moving faster than the speed of light, because we can see the effects. So we should be able to transmit effects faster than the speed of light.
Because the only way it can make those things, the electrons go around a nucleus, they have to go faster than that. So
do you see what I'm saying? Like,
so again, it's just silly. Gravity, it's the same universe. I just don't know how he didn't realize that it's the same universe. We're not in a different universe than the electrons are in right now. They're in the same universe. For their perspective, it's a lot blacker than from our perspective, because we're inside of a matter bubble. But it's the same universe. It's the same empty space all the way down. If there's a piece of empty space right here, it's empty for the electrons and protons too.
what holds them to the nucleus?
It's the gravitation. It's a second gravitational field of.
All right, so obviously it's the charge effect, but yes, it's just force bits, and obviously the two electrons and protons are filtering the force.
Smaller particle that goes even faster than light.
But do you understand my question? Like, how does a particle hold anything to anything?
Oh, I think it's
because it's called the.
Yeah, so he's saying the shadow effect, which is a reference to Lesage essentially, but he should just say push, and that would be the simple part.
No, it's called the shadowing effect.
When which is like a push theory?
Yes.
I see.
That makes sense.
Yeah. And so when you have what gives it away is that why is it Coulomb's law and the gravitational equations are identical in this form? It's because they're both gravitic fields, which are random particles in traveling in random directions that will cause orbiting to happen.
But those charges, okay, and that whole effect is really line of sight, and it's all could be understandable in straight line vectors, and that's what, if you just draw a light bulb with a bunch of rays coming out of it, it's a perfectly duplicates what you want to understand as the capacity of it to produce an effect on a surface. I mean, it just works.
Really interesting, because as I was listening, I was thinking about this, where I'm like, I've been thinking a lot about metaphysics, right? And the metaphysics, the way that I use that word is to say that everybody has a set of rules that they use to talk about the world. We all.
So, yeah, she's using concepts and using them pretty well and tying stuff together, but I would never use the word metaphysics, because that's just religion, frankly. That's just crap. So don't bother using that word. And just say that we're all distracted, okay, by our niches and our particular, our expertise, you could even argue, our, profession, or, what we've had a different amount of exposure to, and all of that biases us in some way or another. But we're not necessarily biased by bad information. So metaphysics would be people biased by woo, listening to gurus and popes, versus people who are just specialists and they don't have enough general knowledge.
have slightly different ones. People that tend to be of a school of thought tend to have similar ones, like all religions have one metaphysics versus, like, the metaphysics of Christianity versus Buddhism, of, like, physics versus biology. An economist sees everything through the lens of economics. Like, everybody's got metaphysics. And
so I just wouldn't agree with that. So the biases, you could just, you could really have a standard that just says, I'm going to start looking for the truth when you're 10 years old. And, and your biases, I'm not going to waste too much time on extraordinary theories that don't even have ordinary evidence.
And I think that you can take the same mathematical relationships and start with a different metaphysics. Either it's push or it's pull. And you can just...
So that's not a mathematical subject, and it's not, but so that's the source, though. Yes, that's what you really have to do, is you have to narrow the subject somewhere. And it's either evolution or God. Okay, well, yeah. You can make that choice and then understand, okay, let's just have a conversation about DNA molecules and, what kind of abstraction you're allowed to create out of them.
Describe all of them in exactly the same way, except inverses of each other without violating any principles. And
yeah, the only thing I would argue is that you don't have we cannot find a physical mechanism for a pull. We can for a push. We have collision, but we can't find one for a pull.
Pull plays a huge part in the body all the time, like even with...
So pull plays a huge part in the body? No, it really doesn't. So that's, it's just such a simple argument. What is an elemental push? It's automatically woo. So if you tell me here's an elemental push, I have two elements this far apart. Now they're going to move into each other. How do they do that? Okay, there's just nothing. There's no way to say they can possibly do that. So, without just invoking woo. Where hitting each other, yeah, that makes perfect sense. Crashing makes sense. Okay, calling missing, there's just no way they could have the event of their interaction except to be colliding. There's just no other way for it to happen, and that's not a pull. Colliding isn't a pull.
Water, like Michael was talking about earlier, like water is entwined, like their surfaces enmesh and they pull on each other. You get tensions that occur.
I am having flashbacks to the conversation that you and David...
So this is a little bit too, weird, water, giving water a whole bunch of properties.
Had many moons ago on the podcast, which you guys actually had this exact same
really?
conversation.
Oh, yeah.
And David was like, even pull is push, because you have
Yes,
this thing
it is.
that's...
I actually wrote that into our book that's just coming out
Yeah,
soon.
here's one that I like to, for those in the audience. Get your coffee cup and pull it toward you. What are you doing?
That's right. I remember
right.
now.
Yeah, your doorknob, anything. Right. All pulls, all things that could look like a pull can be understood to be an inverted push.
You're pushing the handle.
I made it into our book. I'm proud to say I was...
You push on a rope. It's just a fact. You're pushing on it.
working on it this
Well,
morning.
that was my dad. My dad actually did that.
All
one.
right,
I
I'll give him a
can't
shout
take
out
credit.
then.
Well, look, David, I think that we should talk about AI, but the chat is having a conniption over the fact that I told them that I was the last person, so I think we're going to call one more name.
Yeah.
Right. So I guess there's some people who just can't stand this. I have to show up every week, and I never win my opportunity, and I don't want to play anymore. And yeah, I'm going to try to avoid that. Yeah, I don't want to play that. The fact that they can't, I'm just saying. Well, they're relatively young, I would suspect, and so they can't appreciate just how much they're humiliating these poor contestants, and obliging them to, forcibly participate in the show, in the sense of watch it. Where, oh, fuck no. I mean, live, this would be just so horrible for me, right? Because I couldn't just skip over all the crap. I mean, I couldn't stand it, frankly. So anyway, I guess might as well finish.
You
That's
guys got
fine.
it in you for one more? Let's see some enthusiasm in the audience. Anybody? Anybody?
Yeah.
Okay, come on.
I say get one more.
Yes.
All right, thank
I
you.
mean, it's
do
almost
one more.
midnight
Let's do
here,
one
so
more,
I,
guys.
if
All
I
right,
could stay up this
who
late.
do we
then-
have?
All right, thank you, David.
Thank
So-
Right, so they can stay up this late. Yeah, who wants to do that? I mean, frankly, I don't want to sit in a room for 1 week for 2 hours for my 1 minute opportunity to get maybe 2,000 views. Yeah, yeah, sorry, that's not really doesn't seem a very good contract. But anyway, that's the way things work here now, currently. So anyway, just sort of a junk video. But I thought I would do it just for old time's sake. I mean, the Hilster is probably, 10 years ago. Something like that anyway, that we talked. And again, we share some, whatever, 30% of a shared understanding of the flaws in current physics. But he's making the same mistake we all make, is that you jump too far on too little. Because you want to finish it. You want something complete. So you put in something wild, Joker's wild or something. There's just too many wild cards, and you gotta try to minimize the wild cards. I guess it's a simple little statement, and you certainly can't start pretending, that it works when it doesn't. A faster than light force doesn't work. All right, anyway, so till the next time. No, I did in an hour. That's not terrible, right? So it's all, these are all really important subjects, and I guess that's what, to me, the debate needs to be really itemized into, here's the arguments against relativity. And, the first one is, no one's really defeated Newton. So they haven't even gotten past Newton's argument. So it's like, why should I even bother with any other arguments? You haven't even defeated Newton's argument. It's solid. All right, anyway, so till the next time and such and so forth and whatnot. Yeah, I think that's enough.